record. Okay, what are we talking about here? What are these things? Energy levels, main energy levels. We talk about that as sometimes principal quantum number. And they have really easy names, like 1, 2, 3, 4, 5, 6, 7. We don't talk about anything past 7. 7's pretty crazy as it is. So on that first main energy level, and I'm building this up, this is not an accident. You probably want to start note-taking here. I am building this up like it is the floors of a building, with the first floor on the bottom, the lowest main energy level. Guess which one has the lowest energy? The lowest main energy level. Yeah, 1. It's the first floor of the building. It's got the lowest energy. What are the little areas described by Schrodinger's equations that we find electrons in? What are those called? What are those called? Little three-dimensional areas where we find electrons. Orbitals, yeah. And on the first main energy level, what shape of orbital do we have? Spherical, yeah. It's three-dimensional, so it's spherical. And we call it a what? S. S for spherical. And we only have one of them, and it's a little teeny tiny thing. And I've got a picture of it right there. Isn't it cute? Just adorable. Cute little thing. And it's all by itself on the first main energy level. And on the second sort of floor of the building, the second main energy level, what shapes do we have? We have a sphere, we have an S, we got one other. What do you call that thing? Good heavens. Dumbbell? Double drumstick? And they're arranged on 3 axes. Do you want to do the dance to get your blood moving? Excellent, isn't it? Do you want to do the dance just to make Mrs. Berger wonder what the heck's going on? Thank you. She must love being downstairs from my classroom. So there are these things, these dumbbells or these double drumsticks or whatever you want to call them. And because we can arrange them on 3 axes, we get 3 copies. So we have them. And I'll just do that like that. And what are these called? What's the letter name? What's the letter for these? P. These are P orbitals. And on the third main energy level, what do we get? Oh, everybody gets an S, right? We get 3 P's. Everybody gets what all the levels below them had. What else do we add here? D's. And D's, well, D's are a whole different matter, aren't they? D's are just a whole different matter. And there are, though it seems to me that there are infinitely more than 5, there are 5, supposedly, ways to orient these d orbitals. So we get 5 of them. Okay. And we move up to the 4th main energy level. We have an S, we have P's, we have D's, and what else? Remember? F. And we looked at pictures of F's because I'm not even going to try to draw them because they're insane. They're all sorts of weird little bubbles orbiting donuts, orbiting one another. It's just strange. So we get 1 S. How many P's? 3 P's. 5 D's. I shouldn't even try to draw this. I should just do this. How many F's do you suppose we get if you were a betting kind of person? 7! There seems to be a pattern. And here, I'll draw this. It's not anything what it looks like, but I can't do it justice. So there is something beyond the seventh, or beyond the fourth main energy level. It's the fifth main energy level. I know, that's shocking. If you had to guess what we would find on the fifth main energy level, what would you think it would be? You think we'd find an S? Yeah. One S. Guess how many P's? 3. 5 D's. 7 F's. And I'll tell you that the next shape of orbital is called G. Don't even try to wrap your brain around what that looks like. How many G's do you guess there are? 9. 1, 3, 5, 7, 9. That's just weird. This is describing a thing that exists in the physical world, and yet it's counting up the odd numbers. Why would that be? I don't know. I'm not a particle physicist. I'm not even qualified to comment on that. But it's weird. I sometimes find myself thinking about that. Interesting. Okay, so and I think you've probably been filling in this chart as we went. On each main energy level, we add one shape of orbital. We add a shape. That's all. So on the first main energy level, how many shapes are there? 1. On the second main energy level, how many shapes are there? 2. On the third, there are 3. Blah, 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 blah. Each time we add a shape, which would actually be a subshell type, is what it would be the technical term, we add actual orbitals, because each new subshell type has more orbitals with it. So while we only have one S, we have 3 P's, we have 5 D's, 7 F's, 9 G's. We don't really ever get to G's, but that's okay. Here's the thing. In each one of those, so I'm gonna go with 2 because it's the last one that I can reasonably draw. In this 2s orbital, how many electrons are there? 2. In this 2p orbital, how many electrons are there? 2. In this 2p orbital, how many electrons are there? 2. In this p orbital, how many electrons are there? 2. Huh. And to differentiate them on every single level, we use spin up, spin down, spin up, spin down, spin up, spin down, spin up, spin down. That doesn't change no matter how high the energy level is. It doesn't change. It stays the same. Spin up, spin down. It's like addressing things to apartment A, apartment B. And this is just, I sort of previewed this picture a little bit. This gives you some images of the orbitals, S's, P's, D's, and F's. Note that G's are not pictured because they're just too weird to even draw. Though we did see, if you look them up online, you will find 3-dimensional renderings of the D orbitals. I mean, they can be described physically, but they're really weird. So we don't draw them. Okay, so we said that we're doing all this to sort of give an address to the electrons to actually identify where they live, because where they live is going to determine how an element behaves in relation to other elements. We kind of mentioned this. Every single orbital in an atom can hold 2 electrons. That's it. There is not any orbital that can hold more than 2 electrons. The maximum number they can hold is 2. No matter what their shape, no matter what their orientation, they can hold 2 electrons. How many electrons can a single orbital hold? 2! You only have to be able to count to 2. It's very convenient. Okay. All of our knowledge of patterns, all of the things that we just observed about the energy levels and the shapes of the orbitals that are there, it means that we can look at any atom and we can predict how many electrons an energy level can hold. When you had physical science, you learned this in sort of a baby simplified version, because you were still referencing basically the Bohr atom with just the little racetracks. And so there's never any real reason for why the first main energy level can hold 2 and the second main energy level can hold 8. Well, the number of shapes possible is equal to the main energy level. We just said that. So how many shapes are on the first main energy level? 1. How many shapes are on the second main energy level? 2. How many shapes are on the third? 3. The actual number of orbitals on any given level is equal to n squared. Okay, so the number of shapes is equal to main energy level. The actual number of orbitals is equal to n squared. How many electrons can any one orbital hold? 2. So the number of electrons on an energy level is equal to 2 times the number of orbitals. The number of orbitals is equal to n squared. So if we look at the third main energy level, n equals 3. Okay, n equals 3. How many actual orbitals will there be on n equals 3? N squared. 9. So n equals 3 has 9 actual orbitals. How many electrons then? 18 electrons. Well, let's review what we know about the third main energy level. We have 1 s. We have 3 p's. We're up to 4. And I'm just going to copy this a couple times. And 5 D's. So that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. You all right? For my mathematical pattern people, one more slide I want to talk about. Who likes mathematical patterns? Look at that. 1, 1, and 2. 2, 4, and 8. 3, 9, and 18. How many shapes does main energy level 4 have? 4. How many orbitals? 16. How many electrons? 32. So back in physical science, you learned 2, 8, 18, 32, but there was no rationale for that. You were just sort of asked to accept and memorize that the first main energy level can hold 2 electrons, and the second main energy level can hold 8, and the third can hold 18, blah, 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 but you never knew why. This is why, because there are actual physical regions of space where those electrons live. And the number of regions of that space is governed by their energy level. I prefer knowing why to just memorizing stuff. That's just me. So when I first encountered this, it was like little light bulbs going off and little choirs of angels singing in my head. It's like, oh my God, there's a reason for that. That's cool. So hopefully that's somewhat satisfying to some of you too. Okay, so tomorrow, recall quiz looking at patterns, and then we start writing actual addresses for actual atoms of actual elements.